Okay, to finish up this chapter, we're going to look at how we can solve a quadratic equation by using the quadratic formula. This is one that you might already be familiar with, or at least remember having learned at some point. So the quadratic formula just tells us how we can obtain the solution to a quadratic equation just by plugging in those coefficients from the equation into this formula. So if you've got the general quadratic equation, ax squared plus bx plus c equals 0, again, it's important. This formula is only valid when your quadratic equation is set equal to 0. You can get the solution. X is given by negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This is really just a result of solving that general quadratic equation by completing the square. So we're going to derive this formula by completing the square, and then we'll do a little practice using the formula. So here's our quadratic equation: ax squared plus bx plus c equals 0. We're going to begin by subtracting c from both sides. And the coefficient on x squared needs to be 1, so I'm going to divide all terms by a. Now the coefficient on x here is b over a times x, and I'm going to leave some space for the magic. This is equal to negative c over a. Now we're going to Now is where we're going to actually complete the square, right? We're going to be clever about what we add to both sides. Now, our coefficient on x here is b over a. And what we need to do when we complete the square is add, I'm going to cut that coefficient in half and square it, and add that to both sides. So now the way you cut a fraction in half is either to cut the numerator in half, and sometimes, that could be convenient, or what we're going to do is just double the denominator. So half of b over a is b over 2a. Now the reason I added the square of b over 2a to both sides is because on the left side now that is a perfect square. And this is what a perfect square looks like. So I'm going to take the x and take b over 2a, positive b over 2a. And on the other side, now here's where I would usually say we have some arithmetic to do, but we're now going to do some algebra. So I've got some algebra to do. I'm going to write this right side as a single fraction. First I have to square out b over 2a, so that's b squared over, and 2a squared is 2a times 2a, or 4a squared. I'm going to get a common denominator, so I have to multiply the top and the bottom here by 4a. So what we have is negative 4ac over 4a squared plus b squared over 4a squared. I'm going to write that as a single fraction, and I'm going to put the positive term first. So I have b squared minus 4ac. So now we know what the square of x plus b over 2a is. And to solve, we're at the point now where we can take the square root on both sides. We need plus or minus. That's a fraction on the right side, so I'm going to split up that radical over division. On the left now, of course, we have x plus b over 2a. And we have plus or minus square root of b squared minus 4ac over the square root of 4a squared. But we know the square root of 4a squared. Like, we can simplify that radical. We've got a perfect square, we've got a 2 squared and a squared. So we could take out a 2 and an a, and then nothing is left inside, or I guess there's just a 1 left inside. But the square root of 4a squared simplifies to 2a. And now to finish this up, we're going to subtract b over 2a from each side. We get x is negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And look, we're adding and subtracting. These fractions already have a common denominator, so I'll write it as a single fraction. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Huzzah! Now we know why the quadratic formula looks the way that it does. Victory feels pretty good. Okay. Now let's get some practice completing the square. When you're not completing the square, let's get some practice using the quadratic formula. When you're solving by using the quadratic formula, you want to just make sure that it's in standard form, or general form rather, so that it's set equal to 0, and then you just take note of what is a, b, and c. So this is already set equal to 0, and we know that a is equal to 1, b is equal to negative 6, and c is equal to positive 3. So when I am solving by using the quadratic formula, the first thing I usually do is just write out the quadratic formula. The quadratic formula, if you're going to use it, you should know it. It's usually not a thing that will be provided for you. But I always like to tell people, even if you're not sure or if you forget the quadratic formula, you can always rely on completing the square. So there's the quadratic formula. Now I'm going to throw in the values. So negative b, if b is negative 6, negative b is positive 6, plus or minus b squared minus 4 times 1 times 3 all over 2a. That's 2 times 1. Now I'm going to simplify. So 36 minus 12 is 24. And we can actually simplify further because 24 as a radical can be simplified. 24 is 4 times 6, so it's 2 squared times 6. So we could take out a 2. And now we can simplify further because 6 plus or minus 2 times square root of 6, there's a common factor of 2 there. And then those will cancel. And as an exact value, we have 3 plus or minus the square root of 6. Those are our two solutions. Our two solutions are 3 plus the square root of 6 and 3 minus the square root of 6. If your goal was to solve and get an approximation, well, you can get an approximation really from the get-go here, right? Or, you know, if you like simplifying a little bit first, which is not necessarily a bad idea, you could do that starting from here as well. So we would get 6 plus, oops, let me be careful here. I'm going to use parentheses around the numerator. 6 plus the square root of 24, close parentheses, divide by 2, and that's 5.45 approximately. And 6 minus the square root of 24 over 2 is 0.55 approximately. So if you wanted approximations, you know, you can kind of get that anywhere along the way. If you wanted to simplify, write it in simplest radical form, then we have a nice exact solution here. Okay, let's do one more. You know, a lot of the time when I'm solving a quadratic formula or a quadratic equation, I'd much rather just complete the square rather than just fuss around with the formula. I find it a little bit more satisfying to complete the square. But I will even default to using the quadratic formula if I encounter a quadratic equation with inconvenient values, like if I got a bunch of decimals like I see here. So I'm going to begin by getting it in standard or general form. I'm going to make sure it's set equal to 0, and then I can identify A, B, and C correctly. So I'm going to subtract 0.72x from both sides. The other thing is that when you're working with quadratic equations and your coefficients, the numbers that are in the quadratic equation are decimals, it's pretty conventional to approximate your answer. Like, we're not going to get a nice exact, radicals with integers inside. So when we set this up and execute the quadratic formula, I'm actually going to go ahead and get an approximate value for x for our two solutions. In this case, A is equal to 0.37, B is equal to negative 0.72, and C is equal to negative 0.15. I'm going to start by writing out the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b is a positive 0.72 plus or minus the square root of negative 0.72 squared minus 4 times 0.37 times negative 0.15 all over 2 times 0.37. I'm going to first use the calculator and figure out what we have inside the radical. So negative 0.72 squared minus 4 times 0.37 times 0.15 is 0.2964, and then 2 times 0.37 is 0.74, and now I can get the approximate values, putting my numerator in parentheses, 0.72 plus the square root of 0.2964 divided by 0.74 is 1.709 approximately. And then my other solution I get just by subtracting, so I'm going to do second entry to bring up my last entry. Change that to a minus. I get 0.2373. All right. And so now we know how to solve quadratic equations either by factoring, completing the square, or using the quadratic formula.